Good morning, everybody. Thank you for coming in. We have some really exciting stuff for you throughout this day. So we're going to be talking about streaming data analytics in this first session. We're going to talk about multiple topics related to streaming and its importance and how different it is from things that we are more used to, like batch analytics. And at the end, we're going to have a workshop where we're going to dive deeper into some of the building blocks that we have at AWS that enable you to build streaming data analytics pipelines and applications. And we will see ourselves, we will do it by hand. We will build an application that ingests, processes streaming data, and gives you results based on that data. So real quick before we start, who here has a streaming data pipeline of any kind that's currently in production? Okay, so we have a couple people. Okay, great. Okay, so first, what is streaming data? And this is a topic that's coming up a lot in conversations these days, and the nature of streaming data and how different it is from our usual batch processing pipelines. And in this comparison, we can see how streaming data deals with smaller chunks of data that is coming at you at high speed. It's coming at you all the time. And compared to batch processing, which has been around for a long time, where you get larger batches of data, larger chunks of data at certain intervals, maybe say daily or weekly, sometimes hourly, and then you go and you process that data and you analyze it and you get your insights. With streaming data, that pace is much faster. You're ingesting these smaller chunks, and instead of running a processing job nightly or weekly, you are constantly, the processing, the transformation, and the analysis and gaining insights from that data is happening all the time. And some of the use cases that streaming data enables are very, very valuable to many different organizations. For example, if you are trying to monitor your server infrastructure or instances and trying to gain insight into what is going on this infrastructure level, if you are ingesting and processing your logs at a daily kind of interval, you can gain some insights into what is going on, what are the kind of events that are happening on my infrastructure. But when you switch to a different model where you are ingesting and processing your logs in real time, you kind of transform into a different kind of response model. You can respond in real time or near real time to events that are happening on your infrastructure. If you have some errors or problems that you are getting messages about from your website or your app, you can act much more proactively, or what will look to many of your users or all of your user base like a proactive way, because you can make decisions based on that streaming data in real time or near real time. For example, if you are getting, and this is a use case that happens a lot, if you are getting messages that you have user abandonment, user sessions are being abandoned, and users are leaving your application at a rate that is much higher than usual, then you can start looking at this and you can prepare like your help desk and your customer support agents to be ready with a message that they can address the issue or at least look like they know what is going on and can respond with much better messaging to your customers or to your users than if they don't know. So use cases vary a lot. You have things like real-time spending alerts and reporting, clickstream analysis that you can get in real time of how your users are interacting with your content and with your website or your app. Getting these insights is very beneficial because then you can take real-time action based on it. And one of the very important use cases that get enabled in this as well is fraud detection. These text messages or alerts that you get sometimes from your credit card company or your bank whenever you use your card somewhere that you haven't used it before, or if you are traveling somewhere that you haven't traveled to before, you use your card and you get a text message saying, hey, we got this transaction, do you approve it or you don't approve it? And this all without having that near real-time capability, this whole functionality wouldn't have value and it wouldn't be happening. Of course, Internet of Things and smart home devices are also very good use cases for streaming data. These devices create very large amounts of data that are coming at you in very small packets. They might be temperature sensors, thermostats, wearable devices, alarms, whatever kind of device they are. You have a large installed base, and you'll be ingesting and processing data at a very high rate. So why streaming data? It is the value that you get out of it. And the value that you get out of streaming data will really depend on how quickly you can react. When you can react in real or near real time, you will get the most data out of it. And as time elapses, the value of the data will start to dwindle down and diminish. However, there's always that question of what is wrong, where's the place of batch processing along with streaming data? And batch processing is not going anywhere. And streaming data always comes in to add and to be complementary to batch processing pipelines. And actually, the streaming data that you are ingesting a lot of times will end up getting aggregated and being transformed into a batch processing pipeline of some kind, or to a data persistence layer of some kind that you will use some BI or analytics tool to get some long-term insights from it. So in addition to what you're getting, here's what is happening, in the last 30 seconds, for example, across my infrastructure or across the user interactions with my application. You will take that data, you will aggregate it, you'll start looking at it at a high level and see what are the daily, weekly, or monthly trends that you have as well. Now, where do streaming data services on AWS, where are they? Where do they fit? For the most part, they will fit into the data ingestion block that you see on the left-hand side. That's where the Kinesis services fall within the AWS data services ecosystem, as one of the building blocks that enable you to build your data lake and start your analytics journey on AWS. Now we will start looking at the individual services that we have in the Kinesis family of services. Kinesis Video Streams is one of the younger siblings in that family. It was introduced, I think, 2 years ago in reInvent. And it enables you to ingest and process video and audio data. And it's usually used in conjunction with surveillance systems or cameras that you can have that push video feeds into the service. And it is one of the things that we use in the Amazon Go stores, the grocery stores that are unmanned. Kinesis Data Streams is the oldest sibling in that family where the service started. Back, I think, in 2013 is when it was introduced. And Kinesis Data Streams enables you to capture and process and store data streams. And it enables you to build your own custom processing or custom consumer applications, build your own logic, depending on how you want to process the data that you are ingesting in real time or near real time. Kinesis Data Firehose is a more of a streamlined version of Kinesis Data Streams, and it's more targeted at moving data from your producers, the sources that are creating these the data streaming records, into a data store in AWS. And we have options for multiple data stores that you can put that data into, and that fits many use cases where you have already an analytics pipeline that's already established, and you do your processing in a different tool. You don't need to create your own consumer application or your own consumer logic. You can use Kinesis Data Firehose to move that data into that pipeline. Kinesis Data Analytics is where you have that layer of intelligence that you can inject into the data that you are processing. You can start running SQL queries on the data that you are streaming, and these SQL queries will run continuously to do things like aggregations, to give you the insights that you need from the data. And lastly, we have Amazon Managed Streams for Kafka, which is a service that we have announced in reInvent 2018, where we offer you managed Kafka clusters. And Kafka, of course, is an open source project, and it is something that many of our customers asked us to offer because they already use it, especially in their data centers. So we started offering this service. It's currently in preview, and to accommodate that use case where customers already have Kafka in their infrastructure or in their data center, and they want to continue to use it in AWS. Now let's take a quick look at a couple of typical use cases for Kafka or, Kinesis services for streaming data. One here that we touched upon quickly is IoT devices. We have a large number of IoT sensors that are generating readings or data at a very fast pace, and you can be sending these readings to the AWS IoT service, and using the IoT rules engine, the IoT services rule engine, you can push these data records into a Kinesis data stream, and from there you can have a separate logic or an application that you build in Kinesis Data Analytics to do something like calculating average temperature every 10 seconds, for example, and pushing that data via Lambda to a relational database sitting on MySQL, for example. I'm sorry, if you can raise your voice just a little bit.
Producers, the IoT devices and any other devices, they need to be configured for what the Kinesis data stream or
So you're asking whether the producers are configured to push data into Kinesis data streams automatically. This is a very simple setting where you just give the service the name of your Kinesis data stream, and it will start pushing your data records into it, yes.
that sits on the device itself, the Kinesis, or is it integrated with the API? How is it integrated with the producer?
I'm sorry, I can't hear you.
How does the Kinesis data stream, is it integrated with the API or the agent sits in the devices?
Oh, there are. So you're asking whether how the Kinesis service is being made available to you. Yes. So we're gonna take a look into that. There are multiple ways that you can connect into Kinesis and start pushing your data records into it, and we will look at those in just a few slides.
The earlier slide, it showed Kafka cluster that can be integrated, like can work in hybrid with the viewers and the data center Kafka cluster. It can work in conjunction with the data center Kafka cluster.
You can, if you have Kafka already in your data center, that's where we are giving you Kafka as a managed service in AWS. You can continue to use it if you want to run in a hybrid model, or as you are starting to migrate maybe some or all of your workloads to AWS. I don't know exactly, since the service is still in preview, so there is still a lot of work being done on the service itself. Another option or use case is analyzing logs and ingesting logs in near real time. So as an example of that, we can have our CloudTrail logs, which are the audit logs that record all the API actions that are taken against your AWS resources. You can push these CloudTrail messages or events to a Kinesis data firehose through a CloudWatch event. And then from there, you can compute some operational metrics via a Kinesis Data Analytics application that you build. And after that, use a Lambda function to push some of the metrics data into something like an Amazon DynamoDB table, or if you have other options that you can use, if you want to use a relational database like MySQL or something like that, you can do that as well. And you can also, what the Kinesis services enable you to do is to push the data that you want into S3 buckets that can act as kind of the source of truth for you before you start processing the data. So these records that you're getting from CloudTrail, if you want to push them to an S3 bucket that will act as the source of truth that you can go back to at some point later on, you can do that. You can also push the processed data, push a copy of the processed data into a different S3 bucket later on in the pipeline. Now we're going to start looking at the different Kinesis services at a little bit more depth. So Kinesis data streams, again, the oldest service in this portfolio, gives you a easy to manage and a very cost efficient solution to ingest real-time streaming data. The service is secure. It provides you with server-side encryption and provides for data durability by replicating your data into 3 availability zones. And for any Kinesis data stream, there are basically three components. You have your producers on one side. These can be your servers, your instances, your IoT devices, your mobile apps, your mobile devices themselves. These create the data records. The Kinesis data stream sits in the middle. It ingests all of these data records, and you have your consumers sitting on the other side of the stream, and these consumers dip into the stream, they get the records, and they process them. And for each side, for the producers and the consumers, you have many options in terms of the tools that you can use to achieve that functionality that we're going to be looking at. So as an example for your processing tools or for your consumers, you can use your own custom code on EC2 to do the consumption of your data records. You can use Lambda functions that will get invoked whenever data records are put into the stream, and that kind of will give you that completely serverless pipeline where you don't need to worry about managing instances or servers, and Lambda will invoke multiple or as many functions as needed to process your records as the data volume or the volume of data records grows in your data stream. Or you can do something like pushing your data via Spark streaming on an EMR cluster, if that is your preferred way of processing the data. And after that, your outputs can be persisted into whatever database or data store that you prefer, and you can hook up all of your BI or visualization tools to that data to get your final insights. And one of the great things about Kinesis services is that you can connect multiple Kinesis services together in kind of a chain to achieve the functionality that you have. So you can ingest data via Kinesis data streams and then do your real-time processing in a Kinesis Data Analytics application, and then push all the results through a Kinesis Data Firehose to be persisted into something like a Redshift cluster, or index it in Elasticsearch, or push it to Splunk or an S3 bucket. On the other hand, you can push your data into a Kinesis data stream and then process it in something like an EMR cluster via Spark, or use any of the options we just talked about if you have your code running on EC2 or if you're using Lambda for processing. Now let's talk a little bit more about consumers and about the producers. The producers, you have multiple options there. The simplest one to use is the AWS SDK and the mobile SDK, and these are your best option if you have a low volume producer. If you have a small device or a mobile device that is producing a low volume of records, the SDK is very simple to use to make your put calls into your Kinesis data stream. The Kinesis agent is an application that you can install on your servers or your instances, and it's very well suited for use cases where you want to push logs to Kinesis. Basically, you install it, you configure it to monitor certain directories or log files, and it will sit there, and whenever it detects any new updates or messages written to these logs, it will collect them, batch them up, and send them to either a Kinesis data streams or a Kinesis data stream or a Kinesis data firehose. So you have both options with the Kinesis agent. you're talking in the IoT example? Yes. Correct. Yes. The question was whether this is the way, something like the SDK is what you use to interface as the interface between your producers, if you have something like IoT sensors, and the service itself, or the Kinesis data streams, and the answer is yes.
What do you classify as low volume?
What do you classify as low volume? There is no hard and fast rule. There is, if you're talking about one device that is pushing its own records, then that is kind of something that you can think of as a low volume. But if you have something that is probably like aggregating records from multiple devices or a large volume of devices and then pushing all these records into the data stream, then maybe that's a case where you need to look at something like the KPL or the Kinesis Producer library that we'll talk about right now. But again, there is always room for you to experiment and see which option works best for you, because your decision or the best option for you will depend on things like the size of your individual records and the rate at which you are sending records through the service as well. So the KPL, or the Kinesis Producer library, is a library that we making available to you. It's written in Java, and you can use the KPL for your high volume producers. If you have something, just like I said, if you have an EC2 instance that aggregates records from 100 or thousands of instances and pushes all of these to a Kinesis data stream, then the KPL is probably your best option. The KPL gives you capabilities like aggregation, where it can aggregate multiple data records from your application and put them into one Kinesis data record. And it can also do collection by collecting multiple Kinesis data records and pushing them to the stream via a single HTTP request. So it gives you a lot of capabilities to increase the throughput of your data. It also gives you things, capabilities like having CloudWatch metrics. So it emits CloudWatch metrics data that will enable you to have much better visibility into how your producers are performing. And it also has a built-in retry mechanism for any failures of your records that didn't make it. It can retry and keep retrying these records until they succeed. And on top of these three options that I talked about that we provide from AWS, there are many third-party and open source agents and options that are available for you to connect to data streams and push your data records into them. Now, on the other side of the stream, for the consumers, how you're going to be processing the records that you are ingesting, you have the AWS SDK. It's, again, available to you. Very simple and easy to use. You have Lambda. You can run your Lambda functions in there, again, so you can complete that serverless picture if that's what you are looking to achieve. And you also have the Kinesis client library, which is another Java library that we have written with multiple interfaces in Ruby and Python and .NET that you can use as kind of to handle the low-level functionality of your consumer application. So if you have decided that you want to write your own consumer application and run it on EC2, you only need to worry about writing your own business logic, what you want to do with the data. The Kinesis client library will worry about spinning up the threads and the workers that will dip into the stream, or different shards of the stream, and get the data out of it. It will handle the load balancing of these workers and threads across multiple EC2 instances, especially if you have something like auto-scaling, and the number of EC2 instances in that auto-scaling group will continue to change up and down. Can you repeat that? I'm sorry.
If you want some information to be stored, do you have to handle it on the consumer side, or does the Kinesis itself persist also somewhere as a backup?
So your question is whether the data persists within the Kinesis stream if you want to go back and reread it or replay it. The data in the stream will persist up to a certain period. There's a retention period that's by default 24 hours, and you can extend that up to 7 days. After that, the data will expire. But within that retention period, you can go as many times as you want and reread the data from the stream.
What about recovery? Clusters, dependencies in the cluster, recovery?
There is data durability by replicating the data to 3 availability zones. So, yes?
In your talk to customer feed, you both produced, I was wondering if you can aggregate any generic patterns that people have used for consumers and producers, specifically for the industry or
So your question is about whether there are certain patterns of which tool to use on the producer and on the consumer side. It really runs the gamut. There's huge variety there, and depending on the volume of data and how you want to process it and consume it, people use very variety of tools. If you have something like, if you are using something like the KPL as your producer, then you will probably be using the KCL on the other side, because the KCL by default can handle the deaggregation of the records if you are doing aggregation on the KPL, for example. So there are some synergies between the two, but there are customers who use the KPL on one side, and they run Lambda, and Lambda has a module that you can connect to it, a library that can handle the deaggregation of records as well.
you're using on the right side of the pipeline data analytics, I guess, as well. Is there a specific limited set of users that need to use that KPL or something like that? You sort of a variety.
Okay, so your question is if you are using the Kinesis Data Analytics to process your data, do you have the same option or the same array of options to push the data to after they get out of the data analytics?
Producer side, are you limited to a set of producers, or you still have one channel?
No, it's agnostic to what is on the producer side. Yeah.
So how is the offset management done on the consumer side?
How is the offset management?
Yeah, so let's say I consume a set of data
Uh-huh.
process on the consumer side, and then something happens, like an exception or
Mhm.
dispatch, and I want to go back and read the same data again.
Okay.
How is the offset management done?
Okay, so the question is how is the offset management handled, and if there are data that you have processed and then some kind of failure happens and you need to go and reread it. There are markers within the stream. They're called shard iterators that act as these markers that you can basically tell or use the shard iterators to read from certain positions in the stream. Some of them can be on the, you can ask the service to take you to a certain timestamp or to a certain record number, or something like if you wanted to take you to the latest record in the stream or the very first record in the stream. So there are multiple markers that you go to replay or reread your data.
Do I have to use the KCL for the offset management, or the markers are
The markers
available?
are available. The question, the second question was, do I have to use the KCL to get these markers or the shard iterators? And the answer is no. You can get those if you're using the SDK and issuing get record calls. Yes. You can. There is Kinesis. The question was, do we support multiple connectors on the consumer side or multiple consumers? And you can connect or in the Kinesis enhanced fan-out model, you can connect up to five consumers to a shard in Kinesis. Okay. This is a very kind of high-level look at some of the tools that are available to you, both on the producer side and on the consumer side. I'm not going to go through all of them one by one, but just to give you a very quick idea about the ecosystem and the variety of tools that are available to you if you want to interface with the Kinesis data streams. Now we want to talk a little bit about capacity and scaling in Kinesis data streams. So a Kinesis data stream consists of one or more shards. And a shard is a unit of capacity. And it is where you'll find that most of the limits in Kinesis data streams are applied. So one shard will give you a write capacity of 1 megabyte per second or 1,000 records per second, whichever you hit first, and give you a read limit of 2 megabytes per second or 5 transactions per second. We will allow you to go and do a read transaction and pull up to 10,000 records in one transaction. With an upper limit of 10 megabytes, but we will throttle your other calls for 5 seconds after that. You're asking whether if you go beyond this, if it will be queued? No, it will not be queued. It will be throttled, and you will need to, your best option there is to use a back off and retry mechanism. Yeah. So the data records in Kinesis data streams, these are the smallest data unit that you can put in a Kinesis data stream. Partition keys is a value that you need to provide in your put record or put records call when you want to ingest data. And the partition key value will tell or will help the service put your record into a specific shard in that stream if you have multiple shards. So your question about the limit and what you do if you have a higher rate, you can add as many shards to the stream as you like, and each shard that you add will add another 1 megabyte or 1,000 records.
That's per shard.
Yeah, that's per shard. Yeah, these limits are per shard. Yeah, the shard is the capacity unit in data streams.
You don't have to specify shard when you're writing it. The current can add when the capacity increases.
You're asking if the capacity increases with what?
When you write, you specify just a stream as a logical, or you specify the specific slot or shard as a destination. Because if you're specifying that you're limited by that, so you can add as you add more shards, the capacity increases.
You can add as many shards as you want, and you can add these shards at any point in time, and it doesn't interrupt the operation of the stream. But I feel like you have some more detailed use case in mind, and we can certainly pick that up after I'm done here and talk about it in a little bit more detail.
Let me rephrase this question. Basically, what he's asking is, if you have, let's say, 20 shots, right, and you want to write all these 20 shots at the same time, you mentioned that there should be a completion key that points to a shot.
So your question is, if you have multiple shards, because you need more capacity to write more data than the 1 megabyte or 1,000 records.
That was not my question. My question was, you mentioned that you need a completion key, which is basically unique to write into a shot. So if I have 20 shots and I want to write into 20 different shots, I should have 20 different partition keys.
We will answer that question in just a couple slides. Okay, so
Do you have any kind of data compression? Like, is this something that can help you, uncompress the data?
So your question is about compressing data records. The payload that you put into the Kinesis data stream is completely up to you. We do not read it. We do not manipulate it. So if you want to do compression on your side of the data before you put it into the stream, that's an available option. But what the KPL or the Kinesis Producer library gives you the collection and aggregation functions to help you get higher throughput through the stream, through these two functionalities. So you're asking when you are consuming the data, is it going to be decompressed? If you are compressing the data on your side, then you will need to have logic on the consumer side to decompress that data. But if you are using the KPL to do aggregation and collection, and then you are using something like the KCL on the consumer side, the KCL can handle the aggregation of records for you. Okay, the put record and put records are the two calls that you issue to put your record, a single record or multiple records, into your data stream, and get records is what you use on the consumer side to have to dip into the stream, get your records out of it, and start processing them. The retention period, I just talked about that, is by default 24 hours. This is a stream level value. It is not per shard, so you set it for the whole stream. The data will be retained for 24 hours by default, and you can extend that up to 7 days. Sequence numbers are unique numbers that get assigned to your individual data records in each shard as you make your put calls. You'll get the sequence number for your data records in the response of your request. The shard iterator is what I just talked about as well. It is these different markers within the shard that you can go to read data from a certain position within the shard. And these can vary. You have multiple types of shards or shard iterators that you can use, whether you want to go to a certain timestamp or a certain sequence number, or to the oldest or latest record in your shard. Now, if you have multiple shards in your stream, it becomes really important for you to think about the partition key strategy or the partition key values that you use when you put your records in. And the Kinesis service will take the partition key value that you provide in your put record or put records request and run that through a hash function and use the result to map your data record into a certain shard, and it will write that record to that specific shard. So as you start to increase the number of shards in your stream, for most use cases, the majority of use cases, you will want to have a randomized partition key value. And the more random you get, the more of a uniform distribution of your writes across all the shards in the stream you're going to have. And this is what you want to have versus hitting one or two shards especially hard while some of the other shards are sitting underutilized, because then you'll end up trying to write or read sometimes from the shard at a rate that is higher than its limit, and then you will start getting a throughput or a throughput exceeded errors, and your records will get throttled, and you will need to have some retry mechanism to do to try and to retry these records after a certain period of time. The partition key is one of the three values that you need to provide with your put record request. So his question was, where do you get the partition key? And when you do your put record or put records request, you need to provide the data itself, your payload, the data that you want to write, the partition key, and the stream name.
And that's being generated by the producer?
Yes, you need to have logic that generates that partition key value. Yes. The partition key itself, that will need to come, that value will need to come from you. Yeah. So, since we are talking about having multiple shards in your stream and scaling mechanisms, one of the important things for you to know is that adding shards to your stream works a little bit differently. It's not just adding additional shards. It works by splitting existing shards in your stream. And if you are going to reduce the capacity of your stream, you don't need as many shards because, for example, the data rate, the data flow rate that you're dealing with has gone down a little bit. It's cyclical or seasonal or something like that, and you want to reduce it, then you would be merging two adjacent shards together. And these scaling operations are all non-disruptive. Your stream will continue to function, it will continue to ingest data, and it will continue to make your records available for processing while these scaling operations are being executed. So the split call here, it's called split shard call, and with this action, you split one shard into two child shards. What happens is, as soon as the two child shards are created, they will be ready to ingest new data records. But your existing data records that are in the parent shard will still be available to you. That shard will be put in a closed status, but the data records in it will still be available for you to consume and read them up to the stream's retention period that you have configured. After that, these records will be expired. Pretty much the same thing happens when you do the merge. But with the merge, you need to specify two shards that are adjacent or have a continuous range of hash key values. When these two shards are merged, the new resulting shard will be available to accept new data records, and the two parent shards will be in a closed status, retaining their data records up to the stream's retention period. So after we talked about all of that, there's always the question of how many shards do I need? And you can use this simple formula, and you can look at basically your incoming data rate, your incoming records and the data rate that you are ingesting data at, and the outgoing data rate that you are consuming data at, and plug these numbers into this simple formula, and it will give you a number of shards that you can start with. It's recommended that you add just a little bit of headroom to that number, just to give yourself some breathing room in case you have something like a consumer application that has failed and needs to get restarted, or you have a new version, an updated version of that consumer application, and you deploy it, and now it needs to catch up. So it starts consuming records at a much higher rate than before. I'm sorry? It's the maximum of the two values. Yes, because your data rate that you are the total rate of data flow in the stream is based on your write and read.
I think that's the typo.
Okay. Yes, there might be a typo there. Let's talk about this after we're done. And yeah. Okay. Now we'll move on to Kinesis Data Firehose, and like mentioned before, Data Firehose is a more streamlined version of data streams, and it is targeted at use cases where you have streaming data that you want to push into a certain data store within AWS. So with Data Firehose, you can forget about the consumer side, where you don't need to worry about consumer applications, the KCL. You just want to push your data records from your producers into S3, Redshift, Elasticsearch, or Splunk. That's basically where Data Firehose can help you. Data Firehose will buffer your data records it gives you a buffer size that is configurable from 1 megabyte to 128 megabytes, and a buffer interval that runs from 60 to 900 seconds, and whichever one is met first, your data records that are buffered will be written or delivered to the data store that you've configured. Firehose gives you also some flexibility with Lambda transformations of your data. If you want to do format conversions, or you want to do some cleanup of your data, you can use a Lambda function to handle that. But you don't need to worry about shards or scaling or any of the other things that you worried about with data streams. It scales automatically for you. Now, moving on to Kinesis Data Analytics. Kinesis Data Analytics works by breeding and processing and delivering your streaming data using a data application that you configure within the service. And we have two options now for Kinesis Data Analytics. You can run SQL queries on the data. And recently, I think maybe 2 or 3 months ago, we introduced Java. So you can run your Java code against that streaming data as well. So the idea is that you connect to a streaming source, and that streaming source can either be a Kinesis data stream or a Kinesis data Firehose. That's where you're going to be getting your data from. And then you have SQL queries or Java code that continuously runs against that data, and you have results that are continuously delivered to you. You can also have Lambda functions to do some transformation work or data format conversion for you on the data before it's pushed through to the data analytics pipeline. And you can have, you can configure the queries if you are using SQL. You can configure your queries that you want to have run against the data. And we also have multiple templates that are already available to you in the console that give you, regularly used or popular, functionality such as aggregation and anomaly detection. And you can take those, use them as they are, or start building upon them to, to kind of custom tailor them to your use case. So one of the very important questions that using Kinesis Data Analytics or running, SQL queries, for example, against a stream of data is, what are my boundaries? Where, when I run a SQL query, which data exactly am I running that query over? And for that, we use something called windows. And we have 3 types of windows that are available to you in Kinesis Data Analytics. The first one is the tumbling window, and the tumbling window is a very simple window that runs for a certain that opens for a certain number of seconds or whatever your time interval is, and it will give you an aggregation of all the events or records that came in throughout that window. So you will get one result, and each record will be represented only once in a tumbling window. So if you want to do something like calculating an average of, the login failures every 60 seconds, then you can have a tumbling window calculate that for you. The second type of windows is a sliding window, and the sliding window can calculate something like a rolling average. It's a sliding window that moves constantly with time, and you can have, if you have, for example, 4 records that have fallen into that sliding window, as you start to move that window forward, it will start to accumulate more records that will fall into the window, and some records will start to fall out of the window, but you also have the possibility of a record being represented multiple times within that window. And the last type is the staggered window, and the staggered window is suitable for use cases where you can have some inconsistencies within the data that you are ingesting. So for example, if you are ingesting data from a system where some events can come in late, like if you have, for example, like a transient failure or an instance that hasn't reported or hasn't sent its log messages, for maybe 90 seconds, and then it sends a record that's late. There is logic in the stagger window that is utilized to capture that late event and include it with the events that it should have been included in, instead of, or basically use the time that the event took place rather than the time that the event was ingested into the streaming pipeline. So with Kinesis Data Analytics, you basically write your SQL query, you create a in-stream application, and you create a schema to handle the data that you are ingesting. And one of the advantages of data analytics here, or Kinesis Data Analytics, is that it can automatically discover the schema for you. So as soon as you hook up your streaming source at Kinesis Data Stream or Kinesis Firehose into Kinesis Data Analytics and you start it, it can automatically discover the schema for you and create it, and you can adjust it further if you like. And then you create your SQL queries. You write your SQL queries that you want to run against that data, and we call that a pump because it's constantly pushing new data into the query or into the pipeline, run the query against it, deliver the results, then run the query against the new data that it's ingested. Kinesis Data Analytics for Java is this new option that we have announced a few months ago. And we use, we give you a set of open source libraries that are based on Apache Flink, and you can do your development of this code, of the Java code locally, and then you upload a jar file, and we run that for you, and we start scaling the available resources to process your code using the Kinesis processing units. And each Kinesis processing unit has one virtual CPU, 4 gigs of memory, and access to 50 gigabytes of storage. And you can either decide to let us automatically handle the scaling of these KPUs for you, add KPUs with the load of your application, or you can turn off auto-scaling if you don't want to and you want to handle scaling manually for yourself. Now, managed streaming for Kafka, Amazon Managed Streaming for Kafka, the service that is currently in preview. There are certain parallels and similarities between Kinesis and Kafka. Some different terminology, but you can see here that partitions and shards are kind of more or less analogous. And then you also have the topics instead of streams in Kafka is the name used. And Kafka uses more of a pub-sub model versus Kinesis, where it uses the producers and consumers. So why or when you should be using one or the other, that's a decision that's up to you. Each one gives you certain advantages. With Kinesis, you get the typical AWS experience and the APIs that you are used to, and you get a lot of built-in integration with many AWS services. And you have that scaling that is based on the throughput, how much throughput you want, and then you put in a number of or a number of shards that you want to scale to, and that all the provisioning is done for you. You don't need to worry about managing servers or clusters or anything like that. With Amazon MSK, you have the open source compatibility. If it is something that you are already using and familiar with, then you'll be more at home. It gives you maybe more raw performance, and if you are used to provisioning clusters if that's the model that you want to work in, then that's what you're going to get with MSK. Okay, and with this, we got to the end of the presentation. Now we're going to go into the lab. And in the lab, we're going to go to the GitHub page that you guys have in front of you here. This is where you will find all the lab instructions and details. There are also some files that you're going to need to download, but you will find instructions for those as well in the lab instructions. What we're going to be doing basically is building this streaming pipeline and ingesting data through it, running a Kinesis Data Analytics application on it to do anomaly detection, and then seeing the results of that and firing off alerts and notifications whenever the anomaly is actually detected. So when you start looking at the lab instructions, you will see that we have a CloudFormation template that will automate a large part of this infrastructure for you. It will build the Kinesis Data Firehose, it'll give you the code for the Lambda, and it will provision the S3 buckets and the SNS topics. It will ask you for some inputs for your email and phone number, so it can send you the emails and the SMS notifications. What we are going to be provisioning kind of manually are the two blocks in the green frames here. We're going to be using the Kinesis data generator to create the data that we'll be pushing to Kinesis and ingesting. And we're going to be creating the data analytics application and putting in the SQL queries that we'll be running against the data to do that anomaly detection. So we're going to be available for you here. Please let us know if you have any questions at any point in time. There's going to be, more than one of us, and I'm certainly going to be here. So let us know if you have any questions. And thanks again for listening. Thanks for coming in.